Hi, I'm Lee Teschler from Machine Design Magazine. We're here with Wolfgang Dornfeld from Levitronics. And Wolfgang is going to tell us a little bit about a magnetically levitated ball that we see floating here at the Levitronics booth. So Wolfgang, tell us a little bit about the principal operation of this thing.
Sure, thanks very much for the opportunity. As you can see here, our magnetic levitation technology, so everything is basically based on magnetic levitation. So what we do here with this globe, we basically control the magnetic levitation in Z dimension. So that's kind of an old thing. You can find toys on the market which is levitating in Z dimension. So what we do here on our pump systems, we basically add a second layer of magnetic levitation. So we control this in Z dimension, but also in horizontal dimension. And as a next, we basically start to rotate the magnetic field around, which basically makes an impeller, for example, levitated in a liquid and is circulating around without any touching point, without any wearing, without any vibration. So completely magnetic levitated.
And how do you manage to rotate the magnetic field?
I mean, actually what we do is we basically measure the different currents, and we measure that like 5,000 times per second, and in 3 dimensions 5,000 times, so we do 15,000 calculations, and that basically manages to keep the impeller or whatever is levitated in the right position.
What do you use for a sensor technology as a part of this?
Oh, that's basically our own developed sensor technology. So it's not really a sensor, but it's measuring the currents which you need to operate the system. And by measuring the currents, that's indirectly the sensor.
And what kind of a product do you use this principle in?
Yeah, in principle, you can use this levitation technology for many products. But what we have established on the market right now is high purity pumps and high purity mixers. So we basically levitate an impeller within a pump head, and we drive a high purity liquid, for example. And that would be one of the examples we have established in the market yet. Mixer would be another example, and there are more to come.
How big of a component could you practically magnetically levitate this way? Is there a limit in that direction?
I mean, there are some physical limitations, of course, but you can see we started with a very small guy, a very small pump, which was once a blood pump, or developed to be a blood pump, and now we are here with the biggest, like a 4 kilowatt pump. So it seems there is a certain tendency going for like bigger sizes, bigger needs for this technology, and we're still not at the end.
And how does the power consumption for something like this compare with simply putting something on the end of a motor shaft?
Right, you're talking about the efficiency, and we have, in comparison to other pump manufacturers, we can say that we save between 10 and 80% efficiency or energy consumption based on a very effective principle. But of course, depends on the operating point and all that. But it's a very, very effective system.
I see. And since you're talking about pump technology, does the viscosity of the fluid enter into the use of this technology?
Very good question. Yeah, absolutely. So what we can do, as long as you have liquids which are like water-like, the principle of a centrifugal pump works perfect. If you are talking like high viscosities, like more than 100 centipoise, for example, then definitely a centrifugal pump would be not the pump of choice, but you want to look for other technologies then.
Gotcha. That's very good. So, Wolfgang, where does this technology come from? Who developed it?
Yeah, the technology was developed like about 15 years ago, and it was a development which was done at ETH University in Zurich, and then basically it was going to Sulzer Technologies, a big Swiss company, and then spun off to Levitronics in order to develop the technology for the broad market. So it's about 15 years ago. 10 years we have the product on the market, and we're growing at a relatively rapid speed, so it seems to be the right technology for this market.